Hey everybody, Ethan here from WordTech, back with another video for you guys, and this is the return of my series Blips, which is basically a series where we explain something very simple in a very complicated way, which may sound a little bit backwards, but the idea is to give you as much detail about something specific as possible. For an example, say an episode on capacitors that'll be coming up in the future. It's gonna be like a 15-minute episode about capacitors. So that gives you a good example of exactly what this series is supposed to do. Now, this episode here is actually going to be about RAM timings, DDR timings, memory timings, whatever you want to call it, and some of the specifications that surround that, and basically what the different timings mean, because you've probably all heard of like CAS latency and stuff like that, CAS latency, or also known as CL latency, and have been wondering exactly what that is and what the other numbers surrounding that mean. So we'll be explaining that in detail here, but first we're going to be going over a few of the basics of specifications regarding DDR or double data rate RAM. Now, we're not going to be covering a variety of like different types of DRAM or anything like that. The primary thing here is we're going to be talking about timings, but I want to give you a little bit of background on what the nomenclature around RAM means. So first off, DDR, you may be wondering what that is because there used to be SDRAM, which you've maybe seen before, and now there's, DDR, and DDR stands for double data rate. Basically, it means it's able to read and write two amounts of the data simultaneously. Again, this episode's not about that in specific, but basically it is effectively double the speed of what the memory chips are actually clocked at. So if you have memory chips clocked at 800 megahertz, the speed is effectively 1600 megahertz. This is the reason that you see a lot of RAM, DDR RAM, that's like, say, 1600 megahertz. It's actually running at 800 megahertz in terms of the clock speed, but you just divide it by 2 because it's double data rate. So DRAM has a specifications listing next to it. Basically, just by the name of it, you can kind of understand what the speeds are and exactly what it's supposed to be doing. So it is listed DDR XXX in terms of that being 3 different numbers there, or sometimes 4 different numbers, because now we're getting into DRAM that's just so fast, / PCYYY. So what the 3 X's or 4 X's or whatever, that's just a blank spot means, is that is the number that is used to determine the RAM speed or the RAM frequency. So you'll see like DDR 1333, I mean just 1333 megahertz, that is the effective clock speed, not the actual clock speed, which would be that chopped in half. And then you'll see the more less known, not quite as advertised section, which is the PCYYY, which is a different number that is the transfer speed of the memory, or the maximum theoretical transfer speed of the memory. Now, in my personal opinion, that number is not that important to look at anyway, especially if you're going to be changing clock speeds and other stuff like that on your RAM, as well as maybe timings. So that's not necessarily a set in stone number and isn't necessarily important for the scope of this. But in case you guys were wondering, that's what the PC and a number following it means in terms of RAM. All right, everybody, so now we're going to jump into the timings portion of this episode of Blips, which is obviously the portion that you guys all came here to see. So most commonly, you'll see memory timings listed as primarily just the CAS latency, but there's also other aspects to it. So there's 4 different technical latencies in there, and you'll oftentimes just see it advertised as a number with a dash, another number with a dash, another number with a dash, and then a number. Those are 4 separate numbers. They don't go together. The dash is basically just signifying that they're all part of the same category in terms of they are all latency measurements of various different aspects of the memory. And so you'll see it listed usually as just those 4 different numbers there. Now, something to keep in mind before we jump into exactly which numbers are what and what they mean is memory is accessed via strobing rows and then columns. So basically the memory is stored in a matrix, and you've got your bits in the matrix, and basically what happens is you find the row that you need and then you go down to the column that you need, or well, other way around technically speaking. But anyway, point being is you're strobing it, i.e. you're sending electrical signals there repeatedly to determine exactly where the bit you need is. And obviously this happens insanely quick. We're talking in microseconds, but that's just something to keep in mind, is just think of it as arranged as a matrix, and you have rows and columns that are being accessed to find a specific bit of data. So one of the most common measurements you'll see, and one of the ones that some might argue matters the most, is the CAS latency, or column address strobe latency. And this is essentially just a measurement, or is exactly exactly a measurement of how many memory clock cycles will go by before the memory actually delivers the data. So as an example, if you have CL7, cast latency 7, that is 7 clock cycles that go by before the actual information is returned from memory. And that amount of time can be changed depending on your frequency. So going from, as an example, I said prior, 1000 megahertz to 2000 megahertz will actually give you twice the speed improvement if the cast latency stays the same at 7 in that specific instance there. So in terms of the actual memory measurements, you technically have 5, but realistically, generally only 4 are listed. So you have your cast latency, you have your TRCD, more on that in a moment, TRP, TRAS, and your CMD, which is just command. That's the one that's not really commonly talked about, not really as important necessarily. So all of those are actually going to work with the real clock speed of your RAM. So all the information I'm about to give you is with the real clock speed of the RAM, meaning you divide the advertised clock speed, if it's double data rate RAM, which is basically everything, you divide that by 2, so you just cut that in half, and that gets you the real clock speed. So that's important to know, is the measurements are all done with the real clock speed. So we already went over cast latency, and obviously lower cast latency at the same clock speed is going to give you better overall responsiveness and therefore better overall performance. Now, something to keep in mind when measuring these when doing all these measurements is the clock cycle time can be determined by taking 1 and dividing it by the actual frequency. Now, keep in mind that is not the frequency in terms of megahertz, that's the frequency in terms of hertz. So if it's like 1000 megahertz RAM, that's 1 million is the number you need to put there in order to actually determine the clock cycle time. Now, of course, this all makes sense because you have 1000 of those happening every second, or well, in that case, sorry, 1000 megahertz, so 1000 million of those happening every second. And you use the real clock speed again, so that's also really important to keep in mind, is that would be effectively 2000 megahertz memory, as the example that I just gave there. And that can be used with cast latency to determine the total delay in the system in nanoseconds by multiplying the clock cycle by the cast latency. Now, there's more on that later. We have some more details of exactly how that's done after we get through the rest of what these timings here mean. So TRCD is the time between RAS to CAS delay. RAS is the row address strobe, and CAS is the column address strobe. The row happens first, and so this is the delay between the two. It's the delay between when the row address strobe happens and then the column address strobe can happen in order to actually find the bit of data that you're looking for. So, I mean, that's pretty simple, and it's not something that's usually very long, and it's not something that's particularly important, although it's something that obviously you came here to learn. Then you also have TRP, which is the RAS precharge, or row address strobe precharge. And so basically what this is, the precharge, it closes the memory row so that you can then go to a new row to access. So the precharge has to happen before you can leave the row that you're on in the matrix currently. So the active command cannot, which is a command that's given to basically initiate this whole process, the active command cannot be given to another row until the precharge command is given to the previous row. So TRP is really just a measurement between precharge and the next active command. Now, TRAS is the time row address strobe, and basically what this is it's the active to precharge delay. So basically the reverse of what we just talked about. It's the delay after the active command before the precharge can happen. So there is a specific delay when you basically turn a row active. There's a delay before you can close that row. So when you open it, there's a delay before you can close it in order to move on to the next one. And as we said previously, you cannot move on to the next active command until the precharge command is initiated. So that delay there is basically how long that row has to stay open. And CMD, as I mentioned, is not really particularly important, but it's basically, it is the delay between the active command and when an actual command can be initiated. It's a little more complicated than that, but that one is just not particularly important. And for the sake of making this video not 30 minutes, I left that little detail there out. As you know, we go into a lot of detail in most of these episodes though. So one of the most important things that I want you guys to take out of this is determining the true DRAM latency, which is really, really important in terms of determining the speed. And this is more important than cast latency and the like. This is how you really determine what RAM is faster and what RAM is slower. And so this is something important to remember and keep in mind if you're interested in knowing this stuff. And I might even write this portion down in the description so that you can see the exact formula of how you determine the real latency. So real latency is done by taking the clock cycle time in nanoseconds, which I mentioned how to calculate earlier, which was 1 divided by the frequency in hertz, the real frequency. You take that, you take the solution to that, which gives you the clock cycle time in nanoseconds, and then you multiply that by the number of clock cycles. So I'll go over that one more time there. So true DRAM latency can be given by the clock cycle time measured in nanoseconds multiplied by the number of clock cycles. Now, that is using, again, the real memory frequencies. So take the advertised and divide that by 2. And again, in order to determine the clock cycle time, you take 1 and you divide it by the clock speed in hertz. That's really important to keep in mind, because if you try and divide it by the megahertz or by the gigahertz, you're going to get numbers that obviously don't make any sense. So you need to divide it by the actual amount of hertz that are there. So to give an example of exactly what I'm talking about here in terms of determining the true latency, if you take DDR4 2666 memory, you divide that advertised clock speed, 2666 megahertz, by 2, because that's the advertised. This is double data rate RAM. I want to make sure you guys understand that. So you get 1333 megahertz as the actual operating frequency of the memory. So you divide 1 by 1,333,000,000. That is the number that you will divide by, because we're talking, you have 1,333 million hertz. And then the answer you end up getting is 0.75 billionths of a second, or 0.75 nanoseconds. So that's your clock cycle time. And then you take that by, you take the cast latency, which I talked about earlier, and that's an advertised latency that you'll see on pretty much all RAM. That is actually measured. So you can use this equation somewhat easily to actually figure out, what the latency of your RAM is. So you take the clock cycle time and you multiply it by the cast latency. So in this situation, 1333, which again is the actual operating frequency, so it'd be advertised as 2666. You take 1, you divide that in this example here by 1,333,000,000, and that's going to get you 0.75 nanoseconds, which is the overall clock cycle time, and you multiply that by cast latency. Let's use an example of 12, and then you're going to get 9 nanoseconds as your overall true latency. And that's the best way to actually determine real RAM performance. So if you're interested in determining between 2 different sets of RAM and you don't know exactly how to compare that, because say one is cast latency 18 and the other one's cast latency 15, but you're looking at way higher clock speeds on the other one, you can use this formula to determine exactly what kind of performance you're going to get out of it. Now, that's all for this video, guys. Thank you for joining me for this episode of Blips. I know it was a fairly complicated topic there, but obviously that's the whole point of this series here. So don't forget to like and subscribe, leave a comment down below and let me know what you think, and let me know if you want to see more episodes of this. We'll have episodes of this every Friday coming out for you guys on all kinds of different topics. If there's something in specific you want to see, make sure to mention that as well. And check out all the links in the description. We've got links to our website, our Patreon page down there, the forums on our website, as well as some of our other various channels and the like down there. Thank you, everybody, for watching, and I hope you all have a great day.